Hello, so this is another AMC 10A problem. So this was 2023, number 17. So this is slightly challenging question, but there are a couple of ways to do this question, I guess. But as soon as I see the integer side length, so I just like to remember Pythagorean triples, which is I will actually use that, okay? So let me start with draw my picture. So we are told this is A, B, C, D, right? So let's label those. A, B, C, D. And AB is 30. So let's say this is 30. BC is 28. Okay, P and Q lies on BC. Okay, so there is a P right there. Q is somewhere here. So right now I don't really know their place. I just randomly put those points respectively. And the sides of ABP. So let's connect those. Okay, ABP is this triangle. And PCQ, so PCQ. And then QDA, so which is this one. Okay, so all the sides are integer, which is nice. Based on this, what is the perimeter of this middle triangle? Okay, so first things first, like I like to start with listing my Pythagorean triples. So let's go ahead and do that. So most famous one, 5, 3, 4, 5, but let's actually start with 5, 12, 13. And then we have 3, 4, 5. And then we have 8, 15, 17. Okay, so we have 7, 24, and 25. And we have some other ones like 20, 21, and 29, right? So if you check those, you can actually kind of see them. But these are the really common ones that people actually use a lot. So which is why I like to just start with listing those. And the reason why I start with this because since we know the size are integer, maybe it's going to be just Pythagorean triples that we actually commonly know. And if this wasn't the case, maybe we could just use a general, I would say expression. Some people make formula for the Pythagorean triples. There is a way to get those all triples, which is something maybe I can spend time later. But for now, I'll just use these common ones, okay? But to do so, I'll just multiply these numbers by some integers to get something as big as these numbers. So if I multiply this by 2, you will get 2 like 2 times 5, which is 10, and then 24 and 26. If you multiply by 3, so you will get 15, 36, and 39. I think we can still have something more, but let's multiply by 4 as well. So 20, 48, and that will be 52. So these are all the triples. That is just multiply this one. And if you do the same thing with this guy, so you will get like 6, 8, 10. If you multiply by 3, you get 9, 12, and 15. Multiply by 4, so 12, 15, and 20. So you can do one more, maybe like multiply by 5. So 15, 20, 25. Okay, so that will be 16, 30, 34. Multiplied by 3, which is 24, 45, and 51. So which is probably not useful because the largest side we have is like 30, which doesn't look like we are gonna get this bigger, but that's fine. And that should be like 14, 48, and 50. So you can see we cannot really do much more with this one. So let's split this. Okay, so these are some of the multiple of those common triples. Okay, so now let's actually kind of try and check, but with the given numbers. Okay, so what I will try, since we know the ABQ is a right triangle, Okay, and then with one leg is 30. So from the choices, we have 30 is right there. And maybe if I multiply this by 3, you could get something, but I think if you multiply this by 3, so you will get another 30 right here, but that would be hypotenuse. But the leg as 30 is, it looks like this is the only one. So that would be 16, and that is 34. Since there's no other ones that will give us a leg of 30, so which is why we can kind of confirming that this is the case. And since the whole thing was 28, so there should be 12 to get 28. And now we just need to know what would be the other side and the hypotenuse of this right triangle when one leg is 12. So from the choices, we have 12 right here. Okay, so I keep this in mind. And then we have right there, and then we have right there. So we have a few options, right? So, but keep in mind, whenever you have like the 12, the other leg should be not larger than 30. So otherwise that would be all the way to the BC, which doesn't make sense. Okay, so if I choose, let's say 12, 15. So if this is 12, this is 15, right? So this is anything which is gonna be our hypothesis, but that will be 15. If this is 15, this is 28, 28 and 15. I don't think we have a Pythagorean triple with that, okay? So you can double check. You can, let's say you try this first and then you want to this 15. That should be 28. If you do Pythagorean, you will try to see this one as an integer. If not, that's not the case, which is actually not the case, okay? So which is why this doesn't work. And I have 9, 12, 15, or the 5, 12, 13. If this is 5, that's 13. That's 25. 25 and 28 doesn't give another integer. So which is why only possible option is this guy, which is 9. So that should be 15. And 30 minus 9 will be 21. And this is 28. If you use the Pythagorean, so you will see this is going to be 35. But if you don't want to use the Pythagorean, this is also another triple. This is 7 times 3. And this is 7 times 4, right? And 3, 4, and if you multiply by 5, which is going to be 7 times 5, which is also 3, 4, 5 triangle. So now we are good. So since we are told that is all integer, and this is the only one that satisfies, if you add those, that should be 69 plus this one, I guess 84. As you see, just using some of the common Pythagorean triples, we were able to get a number 17. So I hope that makes sense.